So one of my favorite things to do in math, that is evaluating logs. I just think it's super fun, and it's just neat. Okay, so we're going to be given stuff like this. Okay, now we don't know what it's equal to, so I'm going to call that x. Now this is in logarithmic form, which you should have seen from the last video. We're going to rewrite that as an exponential to see what's going on. So there's the base, so 2 to the x is equal to 16. Now, the fun thing here, I like to say fun, because we're trying to figure out, okay, now, what do we do from here? Now, there's a chart that I've given you before that I'm also going to give you in Chapter 8 that shows all the powers of 2, like 2 to the first power is equal to 2, 2 to the second power is equal to 4, 2 to the third power is equal to 8, and 2 to the fourth power is equal to 16. Well, hey, I know that 16 is the same thing as 2 to the fourth. So if 2 to the x is equal to 2 to the 4, then if the bases are the same, 2 and 2, then the exponents have to be the same as well. So x equals 4. So when I ask you to evaluate this, you will write 4 and be happy with it. Okay? It's a lot of steps, but since I've already done this work, I can do this one as well. So this one, if I'm rewriting as an exponential, that would be 2 to the x is equal to 8. And I know that 8 is the same thing as 2 to the third. So 2 to the x is equal to 2 to the third, so since those are the same, x has to equal 3. So when asked what is log base 2 of 8, you'll say, oh, that's just 3. Now, moving forward here, continue this with 3's now. All right, so 3 to the first is 3, 3 squared is 9, 3 to the third is 27, and 3 to the fourth, well, that's 81. So here we go. I'm going to call that x, so I would have 3 to the x is equal to 27. Well, since 27 is 3 to the third, then hey, I know that this right here is 3. That's your answer. And since you notice this, well, okay, well, 3 to the x, we'll call that x, has to equal 81. Well, 81 is the same thing as 3 to the fourth. So then here, what does this have to equal? It has to equal 4. All right. A few more here. Let's see how well we can do. I'm going to call this x of 5 to the x is equal to 25. Maybe you don't need that chart now because you know 5 squared is equal to 25. So that's why this is just 2. Okay. Now 4's though, 4 squared is 16. 4 to the third is 64. So if I call that x, 4 to the x is equal to 64. I know that 64 is the same thing as 4 to the third. So then this will just be 3. Now if you're trying to use your calculator, you either have to have a very fancy calculator just to get these done, or you have to know something called the change of base formula, which we haven't covered yet. All right, really important problems here, ladies and gentlemen. Okay, because if you're looking at that chart and you're thinking, okay, well, 3 squared is equal to 9, that's going to be helpful. Here's the problem. If I call that x, that's still the base. So it's 9 to the x is equal to 3, not 3 to the x is equal to 9, so you're not going to use that. Now, we know something about 9, though, and it's similar to this, that if I took the square root of 9, that would give me 3, okay? So that means, how could I write this instead of a radical? I could write that with a rational exponent. So this would be 9 to the 1/2 power is equal to 3. That's one way to think of that, okay? So this is what I would do then. If you want to do it this way, this would be 9 to the 1/2 power is equal to 3, okay? Square root of 9 is equal to 3, so then x is just 1/2. Now, I don't really like that way of doing it. There's a longer way that actually involves what I kind of put an x through here, all right? So if I can get the same base, then it's easy. So 9 is the same thing, just 9 is the same thing as 3 squared. All right, so just changing the 9 to 3, leaving the x and leaving this 3 as well. So then since this is a power of a power, this is actually 3 to the 2x is equal to 3. Well, that's 3 to the first power, right? So we still, since the bases are the same, we can set the exponents equal to each other. If you have 2x equals 1, how do you solve that? Divide both sides by 2. And you get 1/2 either way. Okay, now let me do it that same way again. Because if I'm rewriting this as in exponential form, this would be 8 to the x is equal to 2. Well, I know 8 is the same thing as 2 to the third. If you like going that way, go that way. So this would be 2 to the third, just replacing 8 times x and equals 2. So this would be 2 to the 3x is equal to 2 to the first. Set those equal to each other. So since 3x has to equal 1, we divide both sides by 3. I get 1/3, which is the correct answer here. Now the other way you could have looked at that is the third root of 8 2? Well, it sure is. Is another way of writing that 8 to the 1/3 power is equal to 2? It sure is. That's the other reason why that's 1/3. All right, down here, the last two, and then I want to get to the actual homework here. So this one's kind of easy. Anytime these match up, the answer is just going to be 1. And here's why. It would be base to the x is equal to 5. Okay, well, those are the same. Have to be the same, so that's why it's going to be 1. Now this one, anytime you have a 1 inside the log like this, regardless of what the base is, most times, this would be 3 to the x is equal to 1. Well, 3 to the 0 power is equal to 1. And if you don't like looking at it that way, you could also have 3 to the x is equal to 3 to the 0. That's another reason why whenever you have a 1 in here, the answer is going to be 0 if you're evaluating. Got to get to these. Sorry, guys. Got to get to them. Anyway, I'm going to rewrite these as an exponential first. So 7 to the x is equal to 1 over 49. Okay. Now, these are the ones that are going to be really difficult for a lot of you because you don't like negative exponents. But it's all right. We'll get there. So I'm going to leave the 7 to the x alone. I'm going to leave the 1 alone. 49, I hopefully all know, is 7 squared. So we're getting closer. We're getting closer. Now, I'm still going to leave that 7 to the x alone, but I can manipulate this. If I want to bring this up here and just rewrite it with a negative exponent, I could. That would be 7 to the negative second power. Don't forget, x to the negative third power would be 1 over x to the third. So if you have a negative exponent, you can bring it to the bottom. If it's on the bottom, you can bring it up if you write it using a negative. So now we have this and this. Set those equal to each other. Negative 2 is what you get there. All right. Similarly, on the second one on this slide, we would have 2 to the x is equal to 1 over 8. We already have talked about the fact that 8 is 2 to the third. If I bring that up here and write it with a negative exponent, I get 2 to the x is equal to 2 to the negative third power. So then if I'm solving or evaluating this, I get negative 3 for my solution there. All right. Yeah, let's get to the homework. All right, we're going to go quickly since you've seen so many difficult examples. This will be 5 to the x is equal to 25. So this is going to be 2 because 5 squared is going to do that. Number 2, we have 2. If I set this equal to x, this will be 2 to the x is equal to 16. Well, I know 2 to the fourth is equal to 16. So that's why it's just going to be 4. Number 4, I have, let's set this equal to x. So 2 to the x is equal to 8. I know 8 is the same thing as 2 to the third. So that's why it's going to be 3. All right. With number 3, if I set that equal to x, this would be 9 to the x is equal to 81. Well, I know 9 squared is equal to 81. So that's why it's going to be 2. All right. All righty, ladies and gentlemen, here we go. I'm going to set this equal to x. So this would be 2 to the x is equal to 1 over 16. Now, 2 to the fourth is equal to 16. So that means 2 to the x is actually equal to 1 over 2 to the fourth. Since it's in the denominator, I can bring it up to the numerator by making it a negative exponent. So then I have 2 to the x is equal to 2 to the not fourth, but negative fourth power. That's why this, when you evaluate it, will be negative 4. That's going to be your answer to number 6. Similar story with number 10. So I'll just jump down there real quick. If I set this equal to x, it'd be 5 to the x power is equal to 1 over 125. So 5 to the x is equal to 1 over, now 5 to the third power is equal to 125. So this is 5 to the third power down here. Now you're going to swing it up here like this. So 5 to the x is equal to 5 to the negative third. That's why when you evaluate number 10, you get negative 3. All right. Now to get to the other evens that I haven't talked about yet, this would be 3 to the x is equal to 9. Hopefully some of you know that in your head. It's just going to be 2. For number 12, that one's kind of gross. I know 2 to the 5th power is equal to 32. I know 2 to the 6th power is equal to 64, though. So that answer, if I said equal to x, 2 to the x is equal to 64. What I'm looking for here is a 6. All right, we're going to wrap these up. I'm going to start with a focus on number 13. 13 is interesting, okay? If you start this off like usual, we have 8 to the x is equal to negative 64. Here's the problem. There's no power that you could take 8 to give you a negative number. So this one we will write as undefined. It just doesn't happen. All right, so there's no real solution to that one. So you can't have that. You can't have a negative inside the log, ever. You can't even have a 0 inside the log. Like number 16, be the same thing, just to give you a hint, okay? However, I'm just going to go down the odds here. So 15, this would be here. If I set that equal to x, 4 to the x is equal to 64. I know 4 to the third is equal to 64. So it has to be 3 for number 15. For number 17, which should also in turn help with number 18, if I set this equal to x, the 6 to the x is equal to 1 over 216. Now, 6 to the third power is 216. Okay, so this would be 6 to the x is equal to 1 over 6 to the third, which is the same thing as 6 to the negative third power. So number 17, the solution you should get is negative 3. Now, last but not least, on number 19, if I set this equal to x, this would be 2 to the x is equal to 16. I know that's the same thing as 2 to the fourth, so you should get here is just a 4. Thank you for listening. Finish the rest on your own. I believe in you.